Hello everyone. So in this video I'm going to solve two special questions regarding mixing problems in the differential equation application. So question 5 and 6. Let's see. A tank has pure water. Okay, so let's set up the differential equation. dA over dt. So inflow information minus the outflow information, right? So inflow minus outflow. A tank has pure water flowing into it. So pure water flowing into the tank means no salt or no pollutant coming into the tank. So the concentration of salt or pollutant coming into the tank is 0 because there's nothing coming in, right? And it comes in at a rate of 12 liters per minute, but it doesn't even matter because 0 times 12 is 0. So 0 minus, we have to talk about the outflow. The contents of the tank are kept thoroughly mixed, that's good, and contents flow out at 10 liters per minute. Okay, all right, so the contents flow out at 10 liters, but the water, now here's the important thing. The special thing about this problem is that the water comes in at a 12 liter per minute rate, 12 liter per minute, and the water goes out at a 10 liter per minute. Now the inflow rate and the outflow rate is different. Now how's that gonna affect us? Well, we want to talk about the outflow concentration, right? We don't know how much salt going out. So it's the A divided by volume. So the volume here is initially the tank contains 10 gram of salt, okay, 10 kilogram of salt. So that's the initial amount of salt, 10 kilogram, and 100 liters of water. So that's the volume, 100 liters. So really, when the inflow rate and outflow rate is different, the volume of the tank is going to change. I mean, think about this. When you pump 12 liters per minute and take 10 liters per minute out, you're going to add 2 liters of water every minute. Think about it. Okay, the rate coming in is 12, the rate going out is 10. So 12 minus 10 is 2. So you are adding 2 liters every time because the inflow rate is higher than the outflow rate. So the volume is changing. So volume is a function of time because it's changing with the time. So the volume is no longer just 100 liters. Okay, so it's 100 liters plus, it's 100 plus because you are adding water, right? Because the inflow is higher than outflow, you are adding water. So how much water you add? 2 liters per minute or 2 times T. Okay, so T is measured in minutes. So after 1 minute, you have 102 liters, right? Because you add 2 liters extra per minute, right? You add 12 and you took out 10. So 12 minus 10 is the amount of water that you add. So really, 12 minus 10, so that's 2, so that's 2 liters adding per every minute, so it's 2 times T. So the volume is actually, so let's write down, so the concentration is actually A over 100 plus 2T. So that's the difference from previous problems. In previous problems, volume was a constant, just a value, because the inflow rate and outflow rate was same. But here it's different. And the outflow rate, now you have to multiply by the outflow rate, that's 10. So really, let's find space here, new space. So dA over dt, inflow, there's nothing coming in. So 0 minus A over 100 plus 2T times 10. That's the differential equation. So it's dA over dt minus 10A divided by 100 over 2T. That's the differential equation. And the initial amount is, initially you have, I cannot remember, 10 grams of salt. Okay, 10 kilograms of salt. This is the differential equation. Okay, so the only difference is that volume story. Okay, let's look at another problem. Sixth one. You don't need to solve this one. I don't expect you to solve this one. Just setting up the differential equation correctly because it's a special case. A tank contains 400 gallon of water. So 400 gallon of water, that's volume. Okay, so 400 gallon of water with 200 pounds of salt in the solution. So that's the initial amount of salt, 200 pound. Okay, water containing 5 pound of salt per gallon is entering. Okay, so dA over dt, so inflow concentration of salt is 5 pounds per gallon. So that's the concentration, right? 5 pounds per gallon. That's concentration of inflow times the rate that comes in is 3 gal per minute. So that's the inflow information. So concentration times rate minus now the outflow, we don't know the amount, divide by the volume. Now let's see, the mixture is allowed to flow out at a rate of 1 gallon per minute. Now you can see the rate that goes out is different from rate that comes in. The rate that comes in is actually 3 gallon per minute and the rate that goes out is 1 gallon per minute. So how much water that you are adding per minute? 3 minus 1, 2. So 2 gallons, you are adding 2 gallons per every minute here, right? So the initial volume is 400. So 400 plus 2t again. It's a function of time, volume. Volume is changing, right? The inflow rate is high. Inflow rate is 3 where the outflow rate is 1. So every time you will add 3 minus 1, you will have 2 gallons introduced to the system every minute. So it's 2 times T. That's the concentration times the rate goes out is 1 gallon per minute. Now think about the units. Even units should match, right? This is what pounds, and this is volume is gallon. So gallon cancel out, gallon cancel out. So it's pounds over minutes. This is pounds over minutes. Everything match. So let's write down the final equation. dA over dt. What's here? 5 times 3 is 15 minus here it's a over a times 1 is a over 400 plus 2t. That's the differential equation. And the initial condition is A0 is 20 pounds. That's the initial condition, together the initial value problem. Okay, so little bit different problems in question 5 and 6 because the inflow rate and outflow rate are different. Okay, all right, thank you very much for watching this video. Bye bye.